Let me record this. So what I'm saying is, being a teacher, we need to know each and every student, because teaching, if you see the definition of teaching, it doesn't mean to get you that literacy no, content in you. It actually means the change, to change the behavior. Okay, there are uh, there are many theories, and it's a science. Teaching is a science. Where we see, if you see the Gandhiji, he has a 3H. He has proposed 3H: head, hand, and heart. So you have to work on all the 3H's as a teacher on a student. So usually we just go on a concept and that's it. But if the student is not motivated, if he's not inspired, he will achieve nothing. Okay, it will make no sense of learning cache memory technologies if the student is not willing to learn. So we have to, some point, we need to understand student mentality, student psychology, and we need to see how student is going, and we have to work not on the concepts but on the psychology as well, on the behavior, so that their behavior changes, they become a better person. Because we have to, as a uh, no learners, we have to all the time see how much better person I became today, what changes I have. If it's stagnant, that means you are dead, as good as dead. If you're not improving, whatever the age you have, whatever the student you are, a student or a teacher or whatever the person you are, if you are stagnant, stagnant means dead. You have to gauge yourself, that how better person you have become, and how much you have learned today, and all those things. So we live in a society, and we have to be, whatever we do, it is to be seen in perspective of society. Okay, so how social we are, how, because tomorrow you can be the assets to the nation. So it will not happen only by learning, like the rote learning. It will happen by changing your behavior, by making you a better person, by making you a person with an intellect, okay, which can think, which can do something for the society, which can do wonders for the nation. And that happens only when your vision is very high. Okay, so teaching is not only about the classes and these concepts of cache memory and all. It means to change your overall behavior. So hopefully, in this online scenario, how much we can do it. But there are, you will see few talks here and there about the behavior, ethics, morality, or something like that, and and making you some kind of a professional, so that you get that professional etiquettes in you. Okay, so that in short you can become a better person, whatever you are and wherever you are. Okay, then let's start about today's topic. That's cache memory. We have started yesterday, I guess, and we saw a lot of things in it, that we know the cache, actually we are actually trying to cache something from the RAM, so that, because the technology of RAM, which is the dynamic RAM, its speed, even though it's not that Adil Rasul has just come up, even though the speed of RAM is not that slow, but it's not fast as we CPU is. But if you put up the cache in between the memory hierarchy, and we know cache is going to really compensate that speed gap. Okay, and but we cannot put everything in a cache, so we're gonna have some cache hit or miss. If it is hit, that's good, and we want to do something that it's all the time cache hit. Okay, because of reference of locality and spatial references and all, we need that. Then we have the cache memory like this, that we have the block, because we talk in terms of blocks, I told you, when you talk about the cache. Okay, but the CPU talks in terms of the words. So okay, but we have a block of data from the RAM into this, but it's a data, it's not just an addressing, it's also the data. Okay, when we well, in the previous class we were reading about the PMT, page map table, that were only the addresses. But here in the cache, it's actually actual data there, because we want to give that data to the CPU. We want to give that data to the CPU. The CPU wants that. So we not only want to access the cache for the addressing of RAM. No, we actually get that data here, and we actually get the data from the cache. Okay, and how to understand that the CPU, whatever it is asking for, is in cache or not, because I told you there are a lot of questions we need to have in our brain. So first question is, we discuss actually these questions only, uh, if you want to put that, for example, something in a cache, you need to know where is it. Okay, so you have to do some mapping from RAM to cache. You should understand what we were reading on the previous class also, associative memory, frame tables. Okay, we created TLB, translation look aside buffer, and we call that is an associative memory. What is the associative memory? Can anyone tell me what is the associative means? If we have an associative memory, what does that mean? Can anyone open up the mic and tell us, participants? Let me, I don't want, you can mute yourself, unmute yourself, okay? Hello, participants. If anyone can, what does the associative mean? Associative memories, what is the specialty in associative memories? And we say associative memories are very fast. Can anyone just tell me, has any information about associative memory?
A relationship between two or more items, sir.
No, don't get database management system into it. You're getting DBMS into it. It's not like that. But nice try. Good. I appreciate that. Who was it? Kazim? It was Kazim, perhaps, right? Yeah. Good. At least Kazim is saying something. Associative, it seems you don't know, so I will not waste time. So basically, when I ask question, it doesn't mean you know, okay? Because you are only learning. I never expect that you know anything, because you are just beginners, and I don't expect that you learn. Yeah, but if somebody knows something, it gives an immense confidence when you say something. So that's why I all the time love that you express yourself. Associative memories has a circuitry on the back, which gives you don't have to calculate anything. It's a fixed circuit on the back to that location to give you the fast access. You understand where it is, and you don't have to go to that location. For example, we were doing in the previous class that in this what we're doing, we have a RAM and we have a PMT, page map table. Then we calculated that offset and all that, right? But if we don't want to calculate that, and we have a circuitry which gets us directly to that location, so it becomes really, really fast. Okay, so that's how we, in caches we have associative caches. Then we have the set associative caches, but this one is the first one, which is the simplest one, is the direct mapping cache. There are actually 3 cache mapping techniques: direct, which we are doing right now, associative, and set associative. Associative will have a circuitry on a back, which will give us quick access to that location. So keep that thing in mind, okay? But we need to keep in mind that whether the first question which we had in our mind was that where will you put that data from the RAM into which block of the cache, right? So you have a data in the RAM and you want to put that in the block of the cache. So which block it will go into? So we said that for that, we have, for example, if we have here 16 locations, okay, then we need to have a 4 blocks in the cache, okay? So because 2 to the power 4 is 16, we have read it about it yesterday, last time. I mean, 2 to the power 4 is 16. So if we have a 16 blocks in the memory, we will have a 4 blocks for the in a cache. It's the simplest way of doing things. We will later improve it on Monday. But now what we say is, if it is a 0 block like this one, this is a 0 block, and who among the RAM will go into the 0 block? So I say like this. This is my we have a stage, okay? On the stage, I have benches. I have chairs. This is the first row chair, then second row chair, then a third row chair. Or the simplest ways, I will have 1 chair, second chair, third chair, fourth chair. I say only among the staff members will sit on a chair first. So that means your Shafat sir can sit here, Junaid sir can sit on this chair, or Mansoor sir can sit here, Qasim sir or Koyum sir or Nofia ma'am, anyone from the faculty can sit on this chair. Okay. Now this chair is reserved. So if I am saying faculty, I know it is going to be on the chair number first. And second chair, I am saying it's a student. So out of you, anyone can be on this. So this one की faculty कहाँ बैठेगा? Student किधर बैठेगा? ये हो गया. The faculty will sit on one chair and student will sit on a second chair. Does it make sense? But if you are asking for Nofia ma'am, you know, when I say if you are asking for Nofia ma'am, will you see the first chair or second chair? What will you see? You will see the first chair, because I told you faculty will be on a first chair. But now there may be junior sir on it. There may be some other on it, because that chair is not reserved only for Nofia ma'am. It is reserved for all the faculty. Okay, so that means in this chair there could be some other guys also, and the person you are finding may not be on that chair. So that means that person will be in the RAM. So first thing कि RAM का कौन सा ब्लॉक किधर जाएगा, हमने उसके लिए बोला कि आपका जो ये RAM है, इसमें जो पहला है, फोर्थ है, आठवां है और 12वां है. मान लीजिए यही फैकल्टी, ये बंदे फैकल्टी थे. They can sit on a first chair, that is 0. They can sit here. Out of these, anyone can sit in 0. And if you have a 1, 5, 9 and 13, they can sit on chair number 1 or in the cache block number 1 or second block. Does make sense? So if you have data out of from 8, it can only be in the 0 block. If you have 4, it can only be on a 0 block, but at a one time it will be 1. We will improve that also, because we'll improve in our cache organization later, because we want more in our cache, right? But right now I am saying if I have a 0 block, 4 block, 8 block, 12 block, it can only be in the 0. But how I will figure it that out is either using the imod 2 to the power k. Okay, last time I told you, if we have, say for example, k is here 4, because we have the 4 blocks, so k is 4, and RAM will be 2 to the power 4. RAM will be whatever the k is, okay. If the k is 4, you have a 4 blocks in a cache, then RAM will be 2 to power that k. So 2 to power k will be RAM. That much of RAM I will have. So there is a relationship between them. So 2 to power 4, 16. So I have a 16 block RAM. So if it is 10, if k is 10, I will have 2 to the power 10, 1 MB RAM. 1024 blocks in a RAM. So it is directly proportional. If k is 10, it's going to be it's exponential, 2 to the power k. Does it make sense? Now how I will figure out which block is in which block of RAM is in which block of cache. That is to be done by either by the k mod this, okay, I mod whatever. Say for example, I am finding this 7. I'm finding this 7. Where will 7 be in this 4 block cache? So I will say it is 7 per modulus of 2 to the power k, because 2 to the power k is how much? Because k here is 2 only. Okay, k here is not 4. K is here is 2 only, because total I'm sorry, I got a little wrong here, because I'm talking of the cache, not of the RAM. So k here is 2. So 2 to the power 2 is 4. So we have 4 this thing. So k here is 2 to the power 2 is 4. So you have to divide by 4. That means this 4 is number of blocks of the cache, not RAM. Sorry, I talked about RAM. It is about cache. Okay. Now, because cache will be after that, 2 to power 4 will be cache. If it is if it is 2 blocks, if it is 2k is 2, cache will be 2 to the power 2, that is 4, and RAM will be 2 to the power 4, that is 16. It's like that. Now whatever that is, so I am saying I want to find the 7. Where will the 7 be in this cache? So I am saying for that, let me clear the clutter, because it is giving a lot of here clutter, so that we can visualize it properly. Okay. Okay. So I am saying that I want to place 7. Where will the 7 go? It is telling me the pinky is telling me it's going to be on a 3. But how I will calculate that? Because I say 7 mod 4, the number of blocks in it. So k here is 2. Okay, what is the K? What is the bits in the cache? Because this will be 0 0, this will be 0 1, this will be 1 0, and this will be 1 1. So I need 2 bits. That is the K is 2, and that means I will have 2 to the power 2. That is 4 blocks in the cache, and in the RAM I will have 2 to the power that 4. That is 16 in the cache. Okay, in the RAM. Now 7% 4. If I divide 7 divided by 4, so 7 को 4 से divide करें, 4 1 is 4, so 3. So it will go into the third block. That is here. It's going to the third. Pinky is the third block, right here. So it's telling me like that. So if I don't want a modulus operator, because we don't do mod operator, this is only for us to understand it. We don't do mod. We do like this. We have the indexes. Okay, we have the index. The index is the first 2 bits. The first 2 bits are the index, and we will see in the RAM we have, for example, we're talking about this 7. Okay, that is here. That is, this is 7, right? 0 1 1 1. Where will it go in the cache? We will see the least significant bits. That is 1 1. We don't have to do anything. It's 1 1. That means 3. It will go into the 3. You take up any data. For example, you take up this. This is 15. Okay, where will it go? It will again go to the pinky. Why? Because the first 2 bits are 1 1. That is 3. It will go here. Okay, you take up any. You take up this red. This one. This is 4. Huh? This is 0 1. I think this is 0 1 2 3 and 4. This is 4. Where will this 4 go? What is the least significant bits? 0 0. Because 4 means 0 1 0 0. So if least significant bits are 0 0, it's gonna go to the red. Okay, the first block. So this is called as an index. The first 2 bits we call it as an index. So if I have any memory long, whatever the memory long I have, the first few bits, the 2 bits are only for, because here K was 2. Okay, but tomorrow if I have a bigger memory and bigger cache, K may be 3 4 5 10. Okay, it may be 10 on also. So that means the first, those K bits, I will say K bits, not just the 2 bits, huh? Whatever, because by tomorrow, if we have a 10 bits K, then that means those 10 bits will tell me where that block will go. So this will answer our first question, where which block of a RAM will go into the which block of the cache in a direct map. Because we're seeing direct mapping is that we will see the first K bits, which are reserved for the index of the cache. This is called index. So this is my index. So first here K is 2. So first 2 bits will tell me where it will go. Okay. So if we have a, for example, 0 1 1 0, so where will it go? Where will this go? Tell me.
Green.
You're saying green, just say in a second block. Okay, because 1 0, yes, you're right, green. 1 0 means 2. So it will go to the second block. It will go in the second block. That's this green, right? Because 1 0 is here. Because the first 2 bits will tell me where will it go. So it answers my question in a direct mapping, that which block of a memory will go into which block. But now question is, like I said, that this chair was reserved for the faculty. So I know the faculty will go only in this chair. Okay, now I understood the faculty will go only into this chair only, right? But now question is, what are the faculty I'm asking, is that faculty on the chair or not? Because it's not possible, because this is reserved for many. Because this first block, red one, is reserved for 0, it is reserved for 2, 4, 8, and so on. So any one of them can be there. Is that person, is that data exactly on it? Because if you see here, let me clear all of this together. Why I'm using the eraser? I can use the lasso all the time. Okay. Now, if I'm having a block 0 0, and I know in the block 0 0, it can be either data from, let me use a different pen, a blue pen maybe. Say for example, here it is apple in it. Here it is boy. Here it is cat. Here it is dog in it, data. Okay. And where will these be? They can only be in this red, right? So there can be, so you are asking for a boy. I know you're asking for boy. It is least significant bits are 0 0. It has to be in the 0 0 block of the cache. It has to be there. I don't have to go other way, right? But now question is boy there? Because it could be boy also here, it could be apple also here, it could be cat, it could be dog, it could be any one of these, because this is reserved for all of these. Does it make sense? Now I need to figure out whether boy is there or not. Then these two bits, these 2 bits on this side, okay, MSB 2 bits, which is called as a tag, will tell me whether it is or not, because I have with the cache now the tag bits. If, for example, there was the 0 0 in it, so that means index is this thing. Yes, it has to be here boy. But if the tag is 0 1, the tag is 0 1, that means these 2 bits are in the tag. That means in this block it is only boy, it's not apple, it's not cat, it is dog, it's not dog. Even though this is reserved for apple, boy, cat, dog, but this time around only boy is there. Who tell me that? Tag. The tag, the last 2 bits, whatever the bits are left out. Okay, if it is 32-bit long, maybe 10 bits are used for the index and 22 bits are used for the tag. Now what will tag tell us? Tag tells exactly which out of them is in the RAM. Does it make sense? So both questions are solved. First question, where will I put my data into the cache? Second question, because that block in a cache can have multiple data from the RAM. So which data this time is in there? The tag will tell us. The tag will tell us. Does it make sense? Let's go to the next. How can I find data in the cache? So that's definitely, we know data, which data is where. We know that using the index. Okay, and that is the index here, as you could see now in this slide. There is an index. So what is the index? MSB 2 bits or LSB 2 bits? Index. LSB ones or MSB?
LSB.
LSB, least significant bits. Okay, the left ones, the right ones, sorry. Okay, what are the right, what are the left ones doing? Left ones are the tag. Because if here this time it is 0 0, okay, I am saying the data which is belonging to is this one. Say this is boy, so that means it is boy here, because tag is 0 0. Okay, because tag will tell us which data it has, because we have also the 4 or 8 or whatever, or where is the 4? 4 is here. This is cat. Cat can also be there, but if I'm asking for cat, it is not there. Why? Because the tag is 0 0. Cat has a tag of 0 1, so it is not there. So if I'm right now, I have loaded boy into this, okay, and I am accessing cat. So cache, we know if the cat, where it could be, it's like if I'm asking faculty, where it could be chair number first. Same way, if it's a cat, because index is 0 0 in the right, 2 bits are 0 0, it has to be in the 0 0 location. Okay, but is it there? The tag will tell us that thing, because tag also is 0 0. That means it's because it's ka index, it's ka tag 0 1 hai, so it is not there. Actually boy is there, right? So that means it's a cache miss. We have to access the RAM to get it. Okay, so that's the thing. So we have a tag, we have an index. Does it make sense about the tag and index? Otufa Gul raises the hand. Ask unmute. Yes.
सर ये जो आपने सिचुएशन बताई, ये 2 raised power 4 की है, जहाँ पे हमें यहाँ से कैशे में 4 है और 2 raised power 4 16 रैम में है. तो कभी सिचुएशन 2 raised power 3, तो तब हमें कैशे में 3 मतलब दिखाना.
We don't use 3, we use the multiple of 2s all the time. Huh? Keep that thing in mind, because हमारा है ना binary में 2 to power 2 3 that becomes 8 and then like that. Huh?
फिर अगर मेमोरी की बात करें, फिर हम 2 raised power 3 भी बोल सकते हैं ना, क्योंकि फिर उस टाइम हमें आएगा 0 0,
वो 8 आएगा. राइट,
फिर वो 8 आएगा. तो ये ऐसे ही मतलब जाएगा, फिर जितना मतलब वहां से आएगा तो उस हिसाब से 3 बॉक्सेस और जो उसका मल्टीपल रैम.
एग्जैक्टली. अगर 32 बिट आपका ऑपरेटिंग सिस्टम है ना, 32 बिट जैसे आपका है 32 बिट का, इसमें से 10 बिट आपकी लगेंगी फॉर द इंडेक्स एंड 22 बिट आपका टैग. So, इसी हिसाब से आप देखो कि आपका कितना ये होगा, कौन आपकी रैम
जी।
कितनी होगी, कैश कितनी होगी,
कैश।
ठीक है
जी,
ना। इसीलिए कभी
Yes,
आप
sir.
आपको 2 GB रैम होती है, आप एक सिस्टम होता है वो
हम्म।
कहता है कि भाई मैं और 2 GB लगाऊंगा, लेकिन यहाँ उसका वो
हम्म।
हिसाब ही नहीं होता, वो लग ही नहीं सकता, बिकॉज उसकी कैश उतनी नहीं है, उसका ये हिसाब नहीं है, तो उसमें आप 8 GB नहीं लगा सकते हो। आप कहोगे मैं चलो 8 GB रैम लगाऊंगा, मैं लगा लूंगा 8 GB रैम, लेकिन कैश का तो उधर से हिसाब आना चाहिए ना उसका, यही मसला,
हम्म।
ठीक है। तो उसलिए फिर वो कहता है कि नहीं मैं सपोर्ट ही नहीं कर रहा, मेरा सिस्टम मैं नहीं कर सकता 8 GB सपोर्ट। इवन मेरे पास एक सिस्टम है उसमें 2 GB रैम लगती है, 4 GB नहीं लगेगी, ठीक है। अभी जो सिस्टम है इसमें 8 GB लग रहे हैं, जो जिसपे मैं पढ़ा रहा हूँ इसमें 8 GB लग के हैं, तो व्हाट हाउ इज इट पॉसिबल, बिकॉज देयर इज दिस थिंग, बिकॉज वी हैव टू डू द एड्रेसिंग, राइट।
Yes, sir.
ओके, और मल्टीपल ऑफ टूज होंगे हमारे पास, हाँ ठीक है, ओके मल्टीपल ऑफ टू, या फिर ऐसे नहीं होगा कि व्हाटएवर दैट इज। नाउ द टैग इज द एड्रेस का जो लेफ्ट वाला पार्ट है, और जो बाकी है वो हो गया इंडेक्स, ठीक है ना। डज मेक सेंस। सो हमें टोटल एड्रेस कैसे निकलेगा, वी हैव टू यूज द इंडेक्स प्लस टैग, ठीक है ना। इंडेक्स अगर 00 है, विल इट बी एलएसबी और एमएसबी, इट विल बी, अगर मुझे इन दोनों का करना है आपस में कि एड्रेस क्या है, सो ये 11 कहाँ पे गया, एमएसबी पे आ गया, एलएसबी पे आ गया, ये एलएसबी पे आएगा, इंडेक्स
MSB.
आएगा एलएसबी पे, और टैग आएगा एमएसबी पे। सो एक्चुअल एड्रेस इज 0110 एज यू कुड सी हियर, ठीक है ना। सो ये मेन मेमोरी का एड्रेस होगा। सो यू हैव टू सी व्हाट आर द इंडेक्सेस एंड व्हाट द टैग इज। सो क्या ये एसोसिएटिव है, क्या ये मेमोरी एसोसिएटिव है, नहीं है, क्योंकि एसोसिएटिव में इंडेक्सिंग ऐसे नहीं होगी, वहां पे सर्किट लगे होंगे सीधे, ठीक है ना। वो डायरेक्ट हमें ले जाएंगे उस लोकेशन पे जहां पे रैम की है, जो भी रैम की लोकेशन है उसमें सर्किट लगा होगा, वो डायरेक्ट ले जाएगा, उसमें निकालेंगे नहीं हम कुछ, 000 देखेंगे 11 है कि क्या है, यहाँ पे हम इंडेक्स देख रहे हैं ना। सो एसोसिएटिव मेमोरी जो होगी वहां पे क्या होंगे, सर्किट्स, वो डायरेक्ट एक्सआर सर्किट्स लगे होंगे और वो हमें डायरेक्ट ले जाएंगे उस लोकेशन पे। ओके, उसके बाद एक और चीज हमारे पास है जो कि कल अतूफा बता रही थी कि वैलिड बिट, क्योंकि क्या होता है कि आपने इसमें डेटा डाला, अब आप इस पे काम नहीं कर रहे हो, आपने इस पे काम किया है, नाउ you will say either it is, you will not delete it, you will not waste time in deleting it, okay, you will only make valid bit 0, you will make valid invalid bit what, okay, shut it down, your class is over. So what I am saying is you will only make valid bit 0, that is it, you don't have to do anything, you don't have to delete and waste time in that, you are done with it, valid bit 0. Now if you are generating the address, it doesn't hamper you, because you just see valid bit 0 or not. So every time you are chucking a system, you are chucking an address, you will first see the valid bit. If the valid bit 0, it doesn't make sense, it's not there, you understand. Okay, go move it. Now look here, we have valid bit, okay. Now tell me about this thing, he is saying the blue one is the invalid. Why is invalid? Because here valid bit is 0, so it's not valid, simple as it is. What about this guy, the pinky, the last one, is it valid? Yes it is.
Yes, sir.
Yes,
Yeah, valid is 1. So what will be the address generated here, generate the address.
0111 0111.
0111. Why 01 first? But first is tag
Because yeah.
after the index. So the location
Yeah.
0111 is there, and that's it, right? Well, keep lappy here, keep lappy on the table, keep the lappy on the table. Yes, well, don't move it, okay, you will break it then, and you can go, okay, just move. Okay, bye. Nice. So we have to get the, so this is valid. So if the valid bit is not 1, that means it's not valid, or you are done with that, you just put up, you don't do anything to the data or something, you just make it here 0, and that's it, we are done. Okay, okay. So this is my this is the circuit of the cache hit. Say this is a 32-bit system, 10 bits are used for the index and 22 bits are used for what? So when you have a like this, now you have a single line and then you have like this, it means it's not a single line, it's a multiple line. We don't show 22 lines like this. It will mess up the circuit. To show it simply in a circuit, if it's a multiple lines, we write like this, then say like this, and then write a number. How many lines we have? So we have 22 lines. Okay, just put up here like this. So we have 10. This is an index. The index will give us the index of it, because if it's a 10, that means 2 to the power 10. Okay, 10, that is 10, 1024 locations we will have in our cache. Okay, and then this is the valid invalid bit. So valid invalid bit will be used in an AND circuit. Okay, if at all it comes true, if an AND this is 1, then only then this is going to happen. If it is not 1, it is immaterial what is in a tag. Okay, it is gonna never be hit, it's gonna be miss, because AND will give output false. Okay, क्योंकि अगर ये 0 हो ना, अगर ये 0 हुआ यहाँ पे, ये बिट 0 है, तो ये कुछ भी हो ना, तो AND को अगर एक 0 है तो वो तो आउटपुट 0 ही देना है ना. So you have to AND your valid bit with the tag. Okay, index will take us, this index bits will take us exactly which block in a memory. Okay, this block, for example, we are saying this block. Okay, it will only happen if what index will take us there. Okay, and is it hit or miss? The valid bit will tell us firstly there if it is there or not, and also the tag, and also the, because tag, अगर tag वो नहीं होता ना जो इसका है, क्योंकि that there is a is equal to sign. So there is an XOR, there is an XOR gate will do the comparison of it. यहाँ पे short में is equal लिखा है कि whatever the tag is coming from here and this tag, they should match. Because this block of data will not be just because any faculty can sit here. So if it is here Junaid, tag is Junaid, and Junaid is coming from this side also, so is equal to Junaid, yeah. If it is here from Mansoor coming up and here is Junaid, so it is not there. Even though the valid bit is 1, it doesn't make, because the tag is not correct. Okay, because this location is for the multiple people, right? So we have to check that also, and we have to AND it with the valid. If at all, if it is Junaid here, it is Junaid here also, but it is 0 here. That means we were done with it. It is not the correct data. Okay, because we don't delete data after doing things. ठीक है ना? समझ आ रहा है? Any questions regarding this? You can ask me if you have any questions.
सर ये पहले कंपैरिजन करेगा, फिर वैलिड इनवैलिड चेक करके रिजल्ट देगा के, मतलब वहां पे कंफ्यूजन हो गया थोड़ा बहुत वो कंपैरिजन, और क्योंकि इसमें एंड में 2 इनपुट्स जा रहे हैं, एक
पहले
तो
कंपैरिजन ही करेगा ना, पहले कंपैरिजन ही करेगा, बिकॉज इट हैज टू डू द कंपैरिजन विद द टैग. अगर टैग ही नहीं है तो फिर वैलिड इनवैलिड को क्या फायदा है, अगर टैग है ही नहीं. ठीक है ना, अगर टैग ही गलत है आपका, बस में आ रहे हैं, ये इरेजर को क्या हो गया. हाँ, अगर आप मैं कह रहा हूँ कि अगर आपका टैग ही नहीं मिल रहा, अगर टैग जो आपका है वो है ही नहीं वो, सो वैलिड इनवैलिड बिट की बाद की बात है ना, पहले देखना है ना कि क्या आपका इसमें वो टैग है कि नहीं. जो बंदा आप ढूंढ रहे हो 00, आपका जो टैग है वो 00 है, क्या यहाँ पे 00 है या नहीं, क्या वो बंदा उधर है कि नहीं. अगर वो पहले टैग ही गलत निकल रहा है, इज इक्वल निकल रहा है, तो ये तो मकसद ही नहीं है ना एंड करने का. फिर आगे ये तो यहीं पर फॉल्स दिखेगा, ये फॉल्स निकलेगा. यहाँ पे अगर 1 भी होगा तो ये फॉल्स देगा, फॉल्स एंड फॉल्स, आउटपुट फॉल्स. ठीक है, समझ आ रही है. टैग यहाँ पर है, तो टैग क्या बता रहा है, टैग क्या बता रहा है, टैग बता रहा है कि क्या वो बंदा उधर है कि नहीं. जैसे ये टैग है, अगर ये 4th ब्लॉक है, यहाँ पे इसका टैग क्या होगा 01. सो यहाँ पे टैग 00 है. सो मैं चाह रहा हूं कि ये क्या ये इसमें है, फॉर एग्जाम्पल ये वाला कैट क्या इसमें है,